Just over a week ago, NASA's unmanned Global Hawk drone completed its first full scientific mission with a 26-hour flight to Tropical Storm Nadine. 26 hours is impressive enough, but it's just the tip of the iceberg. It's the ultimate toy for hurricane researchers, a robotic unmanned aircraft or drone called the Global Hawk. It's capable of flying as high as 60,000 feet and can stay in the air for as long as 30 hours, far exceeding the range of any manned reconnaissance aircraft.
We actually can go to the weather,
providing access to the entire Atlantic basin.
We can fly all the way to Africa, so storms that are just developing as they come off of Africa, we can fly there, we can sit on top of those storms for about 10 hours.
So it's really a kind of a game changer in terms of our ability to get the storms that we can't normally get to and to spend a lot more time over them than we typically can.
And during that time, the Global Hawk uses almost a dozen onboard instruments to collect massive amounts of data and atmospheric samples.
Our main objective is to better understand hurricane intensification, and in particular cases of rapid intensity change, which is a very difficult forecast problem.
During a recent mission to investigate Nadine, the Global Hawk flew in a lawnmower pattern, dropping 35 drop zones that measured temperature, pressure, and wind speed all the way down to the ocean surface, providing 3D imagery of the storm and a bounty of detailed data for researchers on the ground.
This platform gives us a chance to do CAT scans of storms, to sit on a storm and really probe the internal dynamics.
But manned hurricane hunter missions won't end anytime soon. The Global Hawk does have its limitations.
It can't fly into the storm. So we have to probe through the storm. We have to use remote sensing instruments to do that, or dropsondes going down through the storm.
Now, for an added element of expertise, this morning we want to bring in a hurricane specialist, Carl Parker, who can give some insight into why these drones are so important in tracking and forecasting. And in my opinion, Carl, I would think when it comes to reconnaissance and data, the more the merrier.
Oh, absolutely. There's going to be a wealth of data that's coming from these planes as they go out with tropical systems, and that's really going to help us get a better idea of what sorts of environments are going to be optimum for tropical systems to develop. And we're also getting some incredible pictures from these drones. Take a look. This is a photo of Hurricane Earl. It's the eye of Hurricane Earl taken at 60,000 feet. And because they do fly so high, they stay above a lot of the turbulence that the hurricane hunters experience. And they're also well above air traffic in general. When you think about commercial airliners, they fly at about 40,000 feet, so they don't have to worry about that as much. But look at that, just incredible structure in the eye there. By the way, a lot of eyes are not really clear. They've got a lot of low cloud in them. These planes are flown by these guys in the Global Operations Center there, and this is very different flying. Now, they're rated for flying regular planes, but they are flying with a mouse, and it's quite a task. They do that for, again, as long as 30 hours at a time. Maria, back to you.
Hopefully not the same person with the mouse for 30 hours.
A lot of
they
coffee,
do the shifts.
apparently.
My goodness.